Hi everyone. So here's your class data set for the normalized weights that you were inputting into the computer. And at the end of the lab, I kind of ran short on time, but what I was trying to tell you is that you're going to have to calculate the osmotic rate, so the rate of osmosis for each of the um, sugar concentrations, because each of you were assigned a specific concentration, whether it was 10%, 20%. Some of you guys had the distilled water, that would be the 0%. And you're going to have to calculate the osmotic rate at each interval. So at 10 minutes, 20 minutes, uh, 30 minutes. So what you want to do is what would be helpful if you leave one gap between the concentrations. So I'll show you. So it should look something like this. This will make it easier for you to calculate the osmotic rates for each for each of the intervals, and it'll help you just keep track of things. At the beginning, at time zero, obviously here there is no osmosis that has occurred because this is the weight before you dip the egg into the solution. So it's always going to be zero for all of these at time zero. Okay. Then when you move down to the actual intervals, so the different intervals, you're going to have to use this formula, the one that's provided on your homework, where you get the average normalized weight and you subtract it by the previous average normalized weight. And then from that, you're going to divide that by 10, because it's going to be time 2 minus time 1. Since we're doing 10-minute intervals, this is always going to be 10. So I'll show you what I mean. So here, if we want to get the average time of the weight, we're going to use the normalized weights. Okay, so here it's going to be E4. So I'm just going to type in a formula that'll help me get the calculation. So I'll put equals E4, or sorry, not E4, B4 minus the previous weight, right? Because it's weight 2 minus weight 1. So in this case, it's going to be 100. I'll close the parentheses and then I'll divide by 10. It's important that you use these parentheses because otherwise the when it solves the problem for you, if it doesn't have the parentheses, it's not going to subtract first. It'll divide first and then subtract. So it'll do it out of order. So you have to include the parentheses so that it subtracts these numbers first, then divides. So when I hit enter, it'll give me an osmotic rate. So here you can see that it gave me a 0.2. So if I want to increase the significant figures, you just have to go up here in your Excel. Oops, yeah, make sure you select it. So I can always increase the significant figures using these little tools. So once you solve it for one of them, so here I have the osmotic rate for the 10-minute mark, then it's a very simple thing to do because all you have to do is drag it, and then it'll give you the rest of the osmotic rates. Okay, so you can do the same for all of these. Okay, do the same thing for the 10%, 20%, 30%. And it's easier if you do it in Excel because that way you only have to solve it once and then you just drag that answer down and it'll solve it for the rest of this. And if you click on and if you want to make sure that it applied the correct formula, you can just click on one of the values. So let's say I wanted to see how this number was calculated at the 90-minute mark. Then if you look up here at the formula bar, it says B12 minus B11. So yeah, B12, which is here, the 107.3 minus the B11, which is 107. So it did apply the formula correctly. Okay. So yeah, so hopefully this helps you.